Hey everyone, and welcome to section 3.4. In this video, we're going to be talking about graphing linear inequalities in two variables. So let's recall, we have some experience already solving linear inequalities with one variable. Our solutions would be on the number line. They would look like intervals as pictured. Now that we know a little bit more about linear equations, we can start to include a second variable in those inequalities. So a linear inequality in two variables is an inequality that can be written in one of the following four ways. This is not really too surprising, but these are all four of the ways. They all look like ax plus by, inequality symbol c. Of course, a and b are not both equal to 0. So in this video, I'm going to be talking just about some of the general theory here. And in the second video for this section, we're going to be doing some more examples. So just to make sure all our bases are covered, an ordered pair is a solution to a linear inequality if the inequality is true when the values of x and y are substituted into the inequality. So let's look at some examples here. We have y greater than x plus 4, and we want to know if each of these guys is a solution or not. To figure that out, all we have to do is substitute in the variables, with the first coordinate being x and the second coordinate being y. So since 0 is not greater than 4, 0, 0 is not a solution to the inequality. We plug in the 0.16, or we're checking if 6 is greater than 1 plus 4. 6 is greater than 5, go figure. And when we get to the 0.26, we see that it's not a solution because 6 is not greater than 6, it's equal to 6. Okay, and again, negative 15, definitely not greater than negative 1, so negative 5, negative 15 is not a solution. All right, and then we ran into another solution here. Okay, so let's take a second look at what happens when we solve a linear inequality with one variable. So when we do that, we look at our number line picture, and we get something that looks maybe like this. That everything to the right of A is shaded, and there's an open circle at A, depending, of course, on what the original inequality is. But what's important to note here is this point, x equals A, splits the number line in two halves. On one half, the left half, the numbers are not solutions to the inequality. On the right half, they are solutions. So there's a similar idea when graphing the solution set for linear inequalities with two variables. So if we look at the linear inequality ax plus by greater than c, then we can easily get a linear equation from that by just simply turning the inequality symbol into an equal sign, and that gives us a line. And once again, we've split everything into two halves. Namely, On one side of the line, we're going to have solutions, and on the other side, we're going to have points that are not solutions to the linear inequality. So the idea of graphing the solutions to a linear inequality in two variables is much like doing it with one variable. You are dividing the possibilities in half on one side of a particular point or line. In the case of two variables, you're going to have solutions, and on the other side, you're not. And just like with the one variable case, the inequality determines whether or not that dividing point is in the set or not, so too does the inequality affect whether or not this line is in the set. This line, ax plus by equals c, is aptly called the boundary line because it is the boundary between the solution region and the not solution region. All right, so the equation ax plus by equals c serves as the boundary line for all four of these inequalities. But on the left-hand side, when you're talking about greater than or less than, strictly speaking, the boundary line is not included. So when you draw it in your solution set, it's going to look like that. It's going to be dashed to indicate that the line is not included. However, if you're talking about greater than equal or less than equal, the boundary line is included in the solution set. So when you draw your solution set, the boundary line is going to be solid. So let's look at a quick example. All right, so here we're given the task of figuring out which linear inequality this picture is referring to, or which linear inequality in two variables is this picture the graph of. So the first thing that I notice in this picture is that this line is solid. So that indicates that I'm going to have a greater than or equal to, or a less than or equal to. But now we have to determine which one we actually have. So what we're going to do is choose a test point in the solution region. It can be any point that lives in the yellow region. I'm just going to pick kind of an easy one here. That would be the point 5, 0. And then what I'm going to do is compare the sides of this equation. So I'm going to look at y, because it's the left-hand side, and I'm going to look at 1/2 x minus 4. So at my test point, the y value is 0, and I want to figure out what 1/2 x minus 4 is for this particular point. So I have 1/2 times 5 minus 4, which would give us 5/2 minus 4, or -3/2. And what I'm going to do now is compare those two values. Which is the greater value? The greater value is 0, because 0 is greater than a negative number. Which tells me, since the left-hand side is greater when I plugged in a test point, so now all I have to do is just replace the equal sign in the original equation with this greater than or equal to. Okay, that's all for this video. In the next video, we're going to do a bunch of examples.